There's a Swedish company called Modvion who are making wind turbine towers out of wood. Now, I don't know about you, but to me, that always sounds like something you'd see in a greenwashing brochure, right between bamboo toothbrushes and hemp socks. Isn't it just a glorified pile of plywood? What happens when it rains? Or if lightning strikes? Or if a bird drops a cigarette on it? I went to Sweden to find out if this tech is as flimsy as it sounds, or if there's actually something serious going on here. On the surface, this looks like a story about sustainability, cutting emissions, using timber, getting those wholesome natural material vibes. But I was intrigued for another reason. My background is in composite materials, usually fiberglass or carbon fiber, like what wind turbine blades are made from. And wood is basically nature's composite. It's made of long, strong cellulose fibers embedded in a lignin matrix. So in theory, if you align those fibers along the tower axis, you could build something that's strong, stiff, and lightweight. Exactly what you want in a wind turbine tower. But there's also something a little bit fairy tale about this story. Straight out of the Three Little Pigs. Or actually, in this case, the Four Little Piggies, whose wind turbine towers get burned down, get eaten by termites, rot in the rain, and get huffed and puffed and blown down by the wind. So let's go take a look now, starting on the factory floor, where Modvion's engineer Eric Dollerud was kind enough to show me exactly how these wooden wind turbine towers are made.
We built this facility to make the tower, basically. This is like a pilot production facility. Our material is called LVL, which is laminated veneer lumber. It's essentially a very large plywood board made from spruce. It consists of several thin layers of wood that is then bonded together to create this, what we call engineered wood product, basically. These are the boards, 2.5 meters wide, 15 meters long. We bond them together to create a wider board, bond them on the long edge, and then we cut them to the specific size needed for a tower module, which then creates a stack like this. So this stack is prepared and ready for lamination, but still in its flat state. The lamination step is done in this machine. We sandwich all the boards on top of each other with adhesive in between each layer. When it's complete, we pull down the entire laminate stack over these forms, and then we hold it like that until the glue sets, and then the tower wall is formed.
So how many stacks thick?
It varies depending on the design. The tower we built, 14.
And how do you make it cured? Do you have to wet it or steam it or something?
No, we just bend it. The trick to the bendability is the single cross-grain veneer, right? When the grains are running in that direction, the stiffness is quite low in the surface. So that's the trick. Like you bend them when they are individual boards, and when the adhesive sets, they work together to create a more rigid.
And is it a constant diameter tower, or they tape it like a...
No, it's conical, yeah. Slightly. Step after the lamination is done the cutting of the surfaces, which is done in this machine. There's a slit here protruding long into the module. We call these modules. And then on the next module that you want to connect it to, you would have the mirror slit, basically. And then you would insert the steel plate. And when you bond that in, you create the load transferring joint.
Is this the surface finish?
Yes. It's called polyurea. It's a plastic coating, few millimeter thick layer, which has very high robustness and ductility.
Okay, no one who visits this factory could say that it's not a lovely bit of manufacturing. Wood is just soothing. The whole place has this calming Scandinavian aesthetic. Honestly, I find it a real shame that they have to paint the towers white. Imagine a whole wind farm that just looked like a forest of perfectly straight tree trunks. That would be incredible. And yes, it all sounds very sustainable. But while it's never a bad thing to cut emissions or to use more renewable materials, I think the sustainability argument is a bit of a red herring here, at least when it comes to emissions. Wind turbines already have one of the lowest energy payback periods of any energy technology, around 6 to 12 months on average to repay the energy that it took to make it. And it's not like current towers are environmental villains. They're made from steel, which is not only recyclable, but actually recycled at very high rates. If people are worried about wind turbine waste, the tower is the last part that I would worry about. Now, timber can be sustainable, and I don't doubt that Modvion is being extremely careful to source theirs from well-managed Scandinavian forests. But there's always a risk of what's called leakage. You add new demand for certified sustainable timber, and it just displaces other buyers who may end up sourcing from less responsible suppliers elsewhere. So the global outcome isn't always as good as it looks on paper. And let's not forget, this is not solid wood. Laminated veneer lumber, LVL, is held together with a lot of glue. We're talking many layers bonded under pressure to make something like plywood on steroids. That adhesive has its own emissions and durability considerations, and they're not trivial. So I have to say, I'm still not totally convinced that wooden towers are much more sustainable than steel ones, or that there's even any reason to be aiming for that in the first place. Which raises the real question, is there any other reason to move away from steel? After the factory tour, Eric and I headed through to the conference room to talk through it. Let's see if he can make the case for wood. So why wood? What's wrong with steel?
The tensile strength per density is high compared to S355 steel, which is the most typical steel used for wind turbine tower erection. So that basically creates lightweight tower design, right? There's also the sustainability aspect. There are a lot less primary emissions from producing timber material compared to steel on a strength equivalent basis, right?
Wood is nature's composite, so I can understand you get a better strength to weight ratio than steel, but how about compared to like fiberglass?
Well, maybe you can answer that better than me, but the reason that fiberglass hasn't been used for wind turbine towers is probably related to the cost issue, I would say.
Yeah, cost, and also it's hard to imagine how you would put the panels together. Like you get a discontinuity every time that you have a joint, which you would also have the same here.
Yeah, that would be a butt joint that doesn't have a high load-bearing capacity in of itself. It's primarily in the shear direction that you get this high performance. What we use is a steel-reinforced joint in that direction. So we basically cut out slits in the timber members and bond in a perforated steel plate in the slit. And that steel plate basically transfers the tensile stress in the tower wall.
How the laminated structure is better than just having a thick piece of wood.
So any member is only as strong as its weakest cross section, right? When you have a construction grade joist in solid timber, especially in spruce, you would typically see knots and other defects naturally occurring in the material. They can then have quite a significant proportion of the cross sectional area. A knot could be like 30% of a joist cross sectional area. So you could see a dramatic decrease in strength in this cross section. Whereas if you take the timber and slice it apart in very many different layers and shuffle them around and bond them back together, the probability that you would have such a large defect occurring in all different layers is negligible, basically.
So you're not even cutting them up and removing the knots. They're still all there, but now instead of a knot going all the way through, it's only...
When you do this slicing up and distributing the material, the like average strength changes a bit. The max strength in the member doesn't change that much at all, but the characteristic or the bottom of the distribution curve changes a lot. In LVL, it could be 30 megapascals, depending on material quality.
So two main benefits. One, the tower is lighter, and that obviously has benefits for you can have a smaller foundation if you've got a lighter tower sitting on top of it. And then the second thing that you mentioned was lower CO2 emissions and sustainability benefits. Are there other benefits?
It is also cost effective. The cost per load bearing capacity of the timber material is competitive with the steel option. And modularity, this kind of whole concept is inherently modular, right? For large towers, modularity will be a necessity, basically.
Now let's move on to these 4 little piggies. It's a reality that wind turbines do catch fire from time to time, like any kind of industrial equipment. Maybe a lightning strike, maybe a gearbox overheating, or just a grease fire that gets out of control. And when your turbine tower is made of wood, that sounds like a disaster waiting to happen. These things are basically giant matchsticks. Don't you think they're gonna burn down?
Fire is something that you have to take into account for safety of the personnel that is working there. And you also have to design it so that it can withstand the conditions that are present during normal operation to be able to withstand the lightning strike. And timber isn't electrically conductive. A steel tower has this is not an issue, basically. They just conduct the electricity through the tower wall and down to earth. So we fit downcomers and to transmit lightning strikes from the rotor nacelle assembly into earth. There's the standard for this. This is not nothing new. Like, you have timber buildings, stuff gets struck by lightning all day, every day. In the Skara tower, the most recent one we erected, there are air terminals, so basically poles sticking out through the tower wall to prevent strikes to the tower wall.
What about other fires, a gearbox failure, or even if a de-icing system failure, or even arson or something?
Any structure should withstand standardized fire for as long as it takes for the personnel working within it to get out. Really thick timber log is really difficult to set alight, right? And it burns really slowly. When you have a fully developed nacelle fire, right? Yeah. You're not designing to survive that.
Designed to be able to get out in time, yeah.
Okay. And then, so everyone can evacuate and leave the premises, and then the power plant will burn down. That happens regardless of tower material, whether it's steel, concrete, or timber, basically. So
when we do basic safety training for climbing wind turbines, a big chunk of it is about fire. And Eric's absolutely right. We don't spend much time learning how to fight fires up there. What you do spend time on is getting yourself and potentially any injured colleagues out of the nacelle before it goes up in flames. Because once the turbine fire really gets going, you're not putting it out. When the fire brigade shows up, they're not climbing a 100-meter burning tower with a hose. They're there at the bottom to stop burning debris from starting a grass or a bushfire on the ground. So yeah, maybe having a flammable tower doesn't actually change things very much at all. So onto problem number 2 then, insects. The homeowner's nightmare, termites in the timber frame. Termites or other kinds of pests.
you have termites in Australia, right?
Yeah. Do you not have termites?
We don't have termites in the European continent. I think it's the US have termites and South America as well. So I think large parts of the world have termites, but not here. Like in our home market, I think it's only termites actually that eat healthy timber in that regard. Most other pests, they need timber that is already attacked by fungi or like water saturated or something like that. There are methods to handle termites as well, which we plan to employ when we reach those markets, basically.
Okay, that's a nice segue to piggy number 3. If you build a tower out of wood, how do you stop it from rotting? What happens when it gets wet or moldy or starts growing mushrooms inside? How do you prevent water saturation and fungus and, rotting?
We cover the tower with a coating, which is quite thick and quite robust. And that in combination with atmospheric seals, you could call it. We don't ventilate the enclosed air volume to the atmosphere during normal operation. It creates an enclosed system boundary around the tower that does not allow water to pass through it. The timber material itself consists of around 10% water. So in order to significantly change the moisture content, you have to move tons of water into the tower or take it out of the tower. When people are in the tower, you ventilate it, but it's so little time that it doesn't have time to seriously affect the humidity levels inside the tower.
Eric really does have an answer for everything, doesn't he? Almost like he's an engineer at a wooden wind turbine tower company, and his job is to actually think through all of the extremely obvious problems that people like me are going to want to bring up. But piggy number 4 is a tricky one. Anyone who's ever tried to load up an IKEA bookshelf knows how well modular Swedish wooden structures sometimes hold up under stress. Now imagine that your IKEA shelf is 150 metres tall and holding up hundreds of tons of spinning machinery. Replacing a wind turbine tower halfway through its life isn't exactly a weekend trip to the hardware store and an hour with an Allen key. So, will these towers actually last? Okay. And then what about the lifetime? How does that compare to a steel tower and maintenance that you need over that lifetime?
And we design it towards the target lifetime from the turbines, which is from the market, which is now 30, 35 years. The timber is not the limiting factor in the fatigue life of the design, actually. It's the joints.
And what happens at the end of life?
So the plan is to cut the tower down in a controlled manner. Basically take the rotor nacelle assembly off and then using chainsaws, slice off sections of the tower, lift them down, and then cut them up longitudinally into beams and pillars. And they will then be marketable on the construction market. I think this is quite a significant advantage actually compared to other materials, because for concrete it's very difficult to recycle it or reuse it at all. And for steel, it's definitely recyclable and it's done en masse, but it costs a lot of energy to smelt it and reform it into new members. Timber members are marketable locally into the local lumber yards, basically.
It's not too curved for that?
No, I don't think so. You would cut the beams to be maybe, like a construction beam would be maybe this wide or so. Whereas the tower is 8 meter diameter, so there will be a very slight curve on two sides like that, but that you could plane it even.
What about the sustainability of the timber? Is it possible to scale up to a meaningful volume without totally exhausting Scandinavia's sustainable timber?
We source from Nordic producers. We have a sustainable forestry practice in the Nordic countries where we typically the forests grow more than what is taken out of them. It's a long tradition with large-scale forestry going back hundreds of years in both Finland and Sweden and Norway.
I think people are also wary, including myself, because a lot of other sustainable timber projects have, eventually been uncovered to be using logged native timber.
It's a prerequisite to use timber, is that you do it in a good enough way. Our suppliers will be able to support us for quite a large bit of the initial ramp up. It won't be enough for our end goal of thousands of towers per year with the existing LVL production in Europe. So we have to build more LVL factories, basically, or production lines. There are many more countries producing sawn timber, right? There's Canada is huge, and Finland and Norway. And so the availability of timber is not the issue for us. And we're envisioning a cascading reuse scheme in very many steps, right? So we would take down the wind turbine tower, make the load-bearing members for house construction, and then preferably when that building's economic life or lifetime is spent, they would reuse that material again to a lower grade.
Thanks so much to Eric and Modvion for the tour and for patiently answering all of my questions, even the obviously skeptical ones. So, was I convinced? I'm still not sure that wooden towers are dramatically more sustainable than steel, or that sustainability is really the main issue with conventional towers in the first place. So that's not what impressed me the most. What did surprise me is how much of the engineering logic behind this approach makes sense. The emission savings are nice, sure, but what really matters is that wooden towers could offer a practical, potentially lower-cost way to build taller turbines. I covered why taller towers means reaching better wind resource in this previous video. There is a lot to be gained by going taller. Traditional steel towers are constrained by transport. If you want to go taller, you usually need a larger base diameter, but you can't transport a 6+ meter wide cylinder under bridges, for example. So unless you break the tower into more complex segments, you're kind of stuck for height. Modvion's approach offers an alternative way to sidestep that constraint using a lightweight, high-strength material. Modvion has already built a pilot tower on an island near Gothenburg and more recently completed a 2-megawatt tower for a commercial wind turbine, and they continue to scale. I, for one, will be keeping a close eye on how fast they grow. Thanks also to Thomas Koberger and Chalmers University for arranging my Swedish tour. You can see some of the other videos from that trip here. If you enjoyed this video and want to help me keep making independent deep dives like this one, you can join the Engineering with Rosie team on Patreon or become a YouTube member. Members get perks like early access to videos, behind-the-scenes updates, and a chatty Discord where we talk all things clean energy. You can join us at Patreon on this link, and as of the time that I'm recording, I have 0 YouTube members, so you could be my very first one. Just saying. Thanks for watching, and I'll see you in the next video.